The first example is on page 352 of the textbook. It says the volunteers at a food bank arrange a concert to raise money. They have to pay a set fee to the musicians plus an additional fee to the concert hall for each person attending the concert. The relation P equals negative n squared plus 580n minus 48,000 models the profit P in dollars for the concert, where n is the number of tickets sold. We need to determine the number of tickets that must be sold in order to break even, and the number of tickets that must be sold to maximize the profit. So if the food bank breaks even, their profit will be 0. So I'm going to sub in 0 for P here. And this becomes the resulting quadratic equation that we now have to solve for n. Since this side is in standard form, one way to solve it is by factoring. Another way is using the quadratic formula. We can also convert it to the vertex form by completing the square and then isolating n. I'm going to choose to factor. So I notice here that I can factor out a -1, leaving me with n squared minus 580n plus 48,000. And I see that I'm left with a simple trinomial, which I can try to factor using product and sum. The product is 48,000, and the sum is negative 580. And I know the numbers look big, but I recognize that 480 times 100 gives me 48,000. And if I make those numbers negative, they will add up to negative 580. So the two numbers that satisfy the product and sum are negative 480 and negative 100. So the resulting factored form would be -1 times n minus 480 times n minus 100. Okay, the values of n that will make each bracket equal to 0 are n equal to 480 and n equal to 100. And these are the number of tickets that need to be sold for the food bank to break even. Therefore, 100 tickets or 480 tickets must be sold to break even. Okay. What do these numbers represent on a graph? So they represent the X-intercepts. And right here is when profit is 0, and it occurs when 100 tickets or 480 tickets are sold. Now, the next part of the question asks us how many tickets need to be sold in order to maximize the profit. Maximum profit occurs at this point, and the number of tickets sold that corresponds to the maximum profit is actually the x-coordinate of the vertex, and we can find the x-coordinate of the vertex by simply taking the average of the zeros. So if I add 100 and 480 together and divide by 2, I get an answer of 290. So 290 tickets need to be sold in order to maximize the profit. Here's another example on page 356. It says Lila is creating dog runs for her dog kennel. She can afford 30 meters of chain link fence to surround her 4 dog runs. The runs will be attached to a wall as shown in the diagram. To achieve the maximum area, what dimensions should Lila use for each run and for the combined enclosure? So here's a sketch of the 4 dog runs. I have a rectangle here, and this will be the width of the rectangle, and this will be the length. So I have 1, 2, 3, 4, 5 sections of chain link fence that are W units long and one section that is L units long, and all those sections combined have to equal to 30 meters. So here's an equation that I can write using that information. And I also know that we're trying to maximize area and that the area of a rectangle is length times width. Here I have to have two equations with two unknowns, and in order to solve them I have to use the method of substitution, similarly to what we did in chapter 1. So first I'm going to rearrange equation 1 to get L by itself, and that involves subtracting 5W from both sides. And I will call this equation 3. Next, I'm going to sub this third equation I came up with into equation 2, the one that I didn't use for rearranging. So I get 30 minus 5W, which is my length, multiplied by the width. And what I have here is a quadratic relation in factored form. So to give you an idea what the parabola of this relation looks like, I'm going to do just a quick sketch. This is area and width, and it's going to look something like this. And we're interested in the width that would give us the maximum possible area. So we need to know basically the x-coordinate of the vertex, okay, that first coordinate of the vertex. So in order to do that, from the factored form, we can find the two zeros, okay? So if we're looking for the x-intercepts, we know area will be 0, and so we set each of these factors equal to 0 and solve for W. So in the first case, we end up with 5W being equal to negative 30. Dividing both sides by negative 5 gives us a width of 6. And for the second factor, it just tells us that the width will be 0, giving us an area of 0. So here are the two widths that give us an area of 0, and they represent the x-intercepts or zeros. Okay. To find the x-coordinate of the vertex, we just have to take the average of these two numbers. So find a number that's halfway between 0 and 6. So that number is going to be 3. So a width of 3 meters will maximize the area. Now to find the length, we simply sub this value of 3 meters back into our third equation here. And the width ends up being 15 meters. So the dimensions that will maximize the entire enclosure would be 3 meters by 15 meters. We're also asked to find the dimensions of each dog run. So if we know this is 15, this length can be divided evenly amongst the 4 dog runs. And 15, when divided by 4, gives us 3.75. So here, this is going to be 3.75. So each dog run is going to be 3 meters by 3.75 meters, and the entire enclosure, and that will maximize the area, will be 3 meters by 15 meters. So we can write that in a therefore statement. The dimensions, the dog run, and the enclosure that maximize the area are 3 meters by 3.75 meters and 3 meters by 15 meters respectively.